Hello. So we are going to be talking about average rates of change in the first part of section 1.3. Um, so here are some definitions, what the average rate of change is. We'll talk about those in just a minute, but let's just think about this first line to start with, the change in output divided by the change in input. So both of these are important. Maybe we could say the temperature changed 10 degrees, which is interesting, okay? If it changed 10 degrees over 3 months, if that was our input, like that's not a very interesting statement. If we said temperature changed 10 degrees in 4 minutes, like, wow, something big is happening. Who knows what, that would be really strange, right? So the change in input really matters as to how we interpret what the change in output could mean. It also doesn't tell us what happened along the way, right? So if we said the temperature changed 10 minutes over 3 months, presumably in those 3 months, the temperature went up and it went down, and maybe it changed, 30 degrees, some up, in between those 2 points, right? But we're just measuring the first point and the last point if we're measuring the average rate of change. Okay? So we'll do lots of examples where we apply this, but that's the big idea. It's the change in output divided by the change in input. Now I've got a few different mathematical ways that we represent this. So here's one that uses these little funny Greek symbols, little triangles. Those are called deltas. Okay, and delta represents change. Okay, so the way we'd say this is the change in y over the change in x. Or we could say delta y over delta x. Okay, and that means change in y over change in x. And if we think back to our inputs and outputs for functions, usually our x value on the x-axis is our independent variable, right? That's our input value. And y is along the y-axis. That's our dependent variable or our output value for a function. So we can say delta y over delta x. We can also use this notation here, y2 minus y1 over x2 minus x1. Maybe that looks really familiar to you, I hope, because that is a different way to evaluate slope, right? Rate of change is very related to the slope of a function. So this is another way to say delta y, right? y2 minus y1, delta x, x2 minus x1. And down here, we've got a last way that we could represent this. Instead of using y values, we're using function notation, right? So f of x2 is a different way to say y2, right? So those are all different ways that we are mathematically writing the concept of the average rate of change. If you want to know the instantaneous rate of change, which is an interesting thing to think about, you'll have to go to calculus next year, okay? Because that's what calculus studies is instantaneous rate of change. This year, we're just going to talk about the average rate of change. Okay, so let's look at this graph. Here's a question. Find the average rate of change on this interval from -1 to 2. So here's the problem. Let's find the average rate of change for this graph. So we're going from -1 right here to 2. Okay, so our average rate of change. Let's think about our equation, average rate of change. I think I'm going to write this as y2 minus y1 over x2 minus x1. Okay, so what are our x and y values? Well, at 2, our x value is 2 and our y value is 1. And at -1, our x value is -1 and our y value is 4. Okay, so it matters that whichever one we choose, just like slope, if you remember, we can choose either point to be 2 and either point to be 1, but they have to match. Okay, I'm going to choose the one over here to be y2 and x2. So my y value is 1 and my x value is 2. And then my point number 1 is over here at -1, My x value is -1 and my y value is 4. Got to be careful of our minus signs, right? Our x1 value is -1, so it's 2 minus -1. So that's going to give me 1 minus 4 over 2 plus 1. So let's see, -3 over 3 equals -1. Does that make sense? Whoops, can't see that. There we go. Does that make sense? Let's see, the average rate of change from this over this interval from here to here would be -1. Well, let's look. Oops. Why isn't this working? There we go. And okay, here we go. We got this red line going from -1, 4 down to 2, 1. It has a negative slope, right? Our delta gt, I guess for this function, they're calling it g of t, is -3, and our positive t is 3. So instead of x and y's, they're using t and g of t, right? We can do that. And it's sloping downwards from left to right, so we'd expect a negative value. And change in, so in this case, it would be change delta gt over delta t would give us -1. Okay. Let's see, we don't need that yet. Let's do some more examples. All right, let's use a table, right? Instead of a graph, let's do example 3 here. Let's compute the average rate of change from a table. So after picking up a friend who lives 10 miles away, Anna records her distance from home over time. The values are shown in table 2. Find her average speed over the first 6 hours. Okay, so her average speed is going to be, let's write it this way, delta, which is going to be on top. It's going to be the change in output value. So the delta in d of t over delta t, right? The change in distance over the change in time. So the first 6 hours is going to go from 6 to 0, right? So our first output value will be 292, right, for 6. And our first input value is 10 for time 0. And then our delta t will be 6 minus 0. So 282 divided by 6, what is that? Let's see, 47. 47, now I've been a little bit careless about units here, right? What are our units? This is 47, this is miles per hour. Miles per hour. So her average speed was 47 miles per hour. So presumably she's in a car or she's running really fast. Okay, so that was her average rate of change. The information they gave us was her position, the distance that she had gone over different lengths of time, right? And from the distance, we could find her average speed. All right, what if instead of a table or a graph, we have a function? Right, let's find the average rate of change of this function on an interval. Okay, so they give us f of x equals x squared minus 1 over x on the interval 2 to 4. All right, well, here we're going to have to find what our y values are. They tell us our x values, right? x1 is going to be 2 and x2 is going to be 4. How are we going to find the y values corresponding to those? Well, we plug them into the function, right? First, so we're going to have to do a little bit more work than if we have a graph or an equation, right? We're going to have to find f of x or f of 2. So let's find f of 2 is going to be 2 squared minus 1 over 2. So 4 minus 1/2. Let's see, that's going to be 7/2. And then we could find f of 4, right, our x2 value. F of 4 is going to be 4 squared minus 1/4. So 16 minus 1/4. Let's see, what's that? 64 minus 1, so 63/4. Okay, so now we need to find our average rate of change. Let's write it like y2 minus y1 over x2 minus x1. So let's see, this is our 2 value. So our 2 value corresponds to 4, right? So it's going to be 63/4 minus 7/2 over 4 minus 2. All right, we've got fractions, guys. We can do it. We got to find a common denominator up here. So it's going to be 4. So it'll be 63/4 minus 14/4 all over 2. So let's see, 63/4 minus 14, that's 53. 49/4 divided by 2. How do I do this? I've got a fraction divided by 2. I can invert and multiply, right? One fraction divided by another, I could think of this as 2 over 1. So I could write this as 49/4 times 1 over 2. Right, I inverted this denominator and multiplied. So that's going to give me 49/8. All right, there's a lot of fractions and a lot of numbers. Let's see if we got the right answer. Next page. Yes, 49/8. Right, they worked it out. 49/8. We are good. Congratulations. So now what if instead of a function, we have an expression? So let's look at example 6. Find the average rate of change of this expression on the interval 0 to a. Okay, the answer will be an expression involving a. So we're starting to have some letters in here. We're not just going to get a number answer. Okay, well, our interval is still from 0 to a, and we've got this equation. So just like we did with numbers, we're going to have to evaluate that. So let's find g of 0. G of 0 is going to be 0 squared plus 3 times 0 plus 1, which is 1. Right? And g of a is going to be a squared minus 3a plus 1. Okay, doesn't look super friendly because it has these letters in here, but we can deal with variables. All right, so let's find our average rate of change. It's going to be, let's say, so g of a, which is a, so let's write this, first let's write the equation. G of a minus g of 0 all over a minus 0. Okay, well, what is g of a? G of a is a squared minus 3a plus 1, that's g of a, minus g of 0, which is 1, all over a minus 0. Can I simplify this? Hey, yeah, I can. Plus 1 minus 1, right? Those cancel each other out. And that just leaves me with this, a squared minus 3a all over a. All right, I can simplify this a little bit. I'll factor an a out of the top. I get a times a minus 3 all over a. And cancel the a's, and I'm just left with a minus 3. Okay. So once we start getting abstract like this, what does this mean? The average rate of change was a minus 3? It's hard to know, right? It's a little bit abstract. But that's the answer if we're just doing a computational problem like this. Okay, so that is, let's see. Sorry, I'm having trouble navigating my screen here. All right, that is sort of the examples of how to do average rate of change. So let me know if you have any questions.